To select a suitable generator for powering an uninterruptible power supply or UPS system and a phone system, several factors need to be considered. Firstly, understanding the power requirements is essential. For an 18 kV ampere UPS and assuming a 10 kW requirement for the phone system based on the building size, the total power required is approximately 28 kVA. A 60 kW generator is sufficient to provide the required power, offering some headroom for future expansion or additional loads. Secondly, regarding fuel type, natural gas is a cost-effective and reliable option, especially for the continuous operation of the generator. Thirdly, the voltage and phase requirements must be met. 240 volt single-phase power is suitable for both the UPS and the phone system. When considering generator compatibility with electronics, certain types of generators are better suited than others. Brushless generators are highly recommended as they produce cleaner power and are less likely to cause interference with sensitive electronics. These generators typically incorporate an automatic voltage regulator or AVR. The AVR helps maintain a stable voltage output, which is critical for the consistent and reliable operation of electronic devices. Another important factor is the total harmonic distortion, or THD, level. Low THD levels, ideally less than 5%, ensure that the generator provides clean power, minimizing the risk of damage to electronic devices. Based on these considerations, a suitable generator could be a Briggs & Stratton 60Y125 Type 1. This model provides 60 kilowatts of power, operates on natural gas, supplies 240 or 120 volts, is single phase, and features a brushless generator with AVR and a THD of less than 5%. In addition to the generator itself, several other factors must be taken into account for a complete and functional system. 1. An automatic transfer switch is necessary to seamlessly transition between utility power and generator power in the event of an outage. 2. The fuel tank size should be determined based on the estimated runtime requirements. The size depends on how long the generator needs to run during power outages. 3. Regular maintenance is essential to ensure the generator's performance and longevity. Following the manufacturer's recommended maintenance schedule will keep the generator running efficiently. 4. Consider sound insulation measures to minimize noise from the generator, particularly if it is located in or near occupied areas. Finally, it is important to check with local authorities for any codes or permits required for generator installation. These regulations can vary depending on the location and should be adhered to for compliance. In summary, select a generator that meets the power requirements of the UPS and phone systems. Consider a brushless generator with AVR and low THD for compatibility with sensitive electronics, and ensure that an automatic transfer switch, proper fuel tank, and regular maintenance are in place. Also, make sure to comply with local codes and permits. Understanding the technical specifications of generators is important. Generators convert mechanical energy into electrical energy. This conversion relies on the principles of electromagnetic induction. The mechanical energy, typically supplied by an engine powered by natural gas, rotates a set of conductors within a magnetic field. This rotation induces an electromotive force, or voltage, in the conductors, which drives the flow of electric current. The key components of a generator include the engine, alternator, voltage regulator, cooling system, lubrication system, fuel system, and control panel. The engine provides the mechanical power to drive the alternator. The alternator, which consists of the stator and rotor, is responsible for generating the electrical power. A voltage regulator maintains a stable output voltage, which is critical for protecting connected equipment from voltage fluctuations. The cooling system prevents the generator from overheating, while the lubrication system reduces friction between moving parts. The fuel system stores and delivers fuel to the engine. The control panel houses the controls and instrumentation for operating and monitoring the generator. Brushless generators, as previously mentioned, are particularly well suited for powering sensitive electronic equipment. In a traditional generator, brushes are used to conduct electricity between the stationary and rotating parts of the alternator. These brushes can wear down over time and produce electrical noise, which can interfere with electronic devices. Brushless generators, on the other hand, use a more sophisticated method of transferring electricity, eliminating the need for brushes and reducing electrical noise. Automatic voltage regulators, or AVRs, play a crucial role in maintaining a stable output voltage. The AVR monitors the generator's output voltage and adjusts the excitation current to the alternator to compensate for changes in load and input voltage. This ensures that the output voltage remains within acceptable limits, protecting connected equipment from damage. Total harmonic distortion, or THD, is a measure of the distortion of the voltage waveform. A pure sine wave has a THD of 0%, while a distorted waveform has a higher THD. High THD levels can cause problems with electronic equipment, such as overheating, malfunctioning, and reduced lifespan. For sensitive electronic equipment, it is generally recommended to use a generator with a THD of less than 5%. An automatic transfer switch, or ATS, is an essential component of a generator system. The ATS automatically switches the load from the utility power to the generator power in the event of a power outage. This ensures that the UPS and phone system continue to operate without interruption. The ATS also switches the load back to the utility power when the power is restored. The ATS should be sized appropriately for the load and should be compatible with the generator and the electrical system. The fuel tank size should be determined based on the estimated runtime requirements. Consider how long the UPS and phone system need to operate during a power outage. The fuel consumption rate of the generator should also be taken into account. The fuel tank should be large enough to provide sufficient fuel for the required runtime, with a safety margin to account for unexpected delays or increased load. Regular maintenance is essential to ensure the generator's performance and longevity. Follow the manufacturer's recommended maintenance schedule, which typically includes tasks such as changing the oil, replacing the air filter, and inspecting the spark plugs. Regular maintenance can help to prevent problems and extend the life of the generator. Sound insulation measures can help to minimize noise from the generator. Generators can be noisy, which can be a nuisance, especially if the generator is located in or near occupied areas. Sound insulation measures can include enclosing the generator in a soundproof enclosure or installing sound barriers around the generator. Complying with local codes and permits is important. Local codes and permits may be required for generator installation. These regulations can vary depending on the location and should be adhered to for compliance. Failure to comply with local codes and permits can result in fines or other penalties. Here's a deeper dive into the technical aspects. The engine of a natural gas generator operates on the principle of internal combustion, similar to a gasoline engine, but optimized for natural gas fuel. Natural gas, primarily composed of methane, is mixed with air and ignited within the engine's cylinders. The expanding gases from the combustion process drive pistons, which in turn rotate a crankshaft. This rotational mechanical energy is then transferred to the alternator. The alternator is the heart of the generator's electrical power production. It consists of two main components, the stator and the rotor. The stator is the stationary part, containing a set of conductors, typically copper windings, arranged in a specific configuration. The rotor is the rotating part, which creates a magnetic field. In a brushless generator, the rotor's magnetic field is generated by a smaller exciter alternator and rectifier assembly, eliminating the need for brushes and slip rings. As the rotor spins, its magnetic field sweeps across the stator windings, inducing an electromotive force, or voltage, in the conductors. This voltage causes electric current to flow, producing alternating current, or AC, electricity. The frequency of the AC electricity, typically 60 Hz in the United States, is determined by the speed of the rotor's rotation. The voltage regulator plays a critical role in maintaining a stable output voltage. The AVR constantly monitors the generator's output voltage and compares it to a reference voltage. If the output voltage deviates from the reference voltage, the AVR adjusts the excitation current to the exciter alternator, which in turn changes the strength of the rotor's magnetic field. This feedback loop ensures that the output voltage remains within a narrow range, typically plus or minus 1%, regardless of changes in load or input voltage. Total harmonic distortion, or THD, is a measure of the purity of the sine wave of the AC electricity produced by the generator. Ideal AC power has a perfectly sinusoidal waveform. However, in reality, the waveform can be distorted by various factors such as nonlinear loads and imperfections in the generator's design. These distortions are called harmonics, and THD is a measure of the total amount of harmonic distortion present in the waveform. High THD levels can cause a variety of problems, including overheating of electrical equipment, malfunctioning of electronic devices, and interference with communication systems. For sensitive electronic equipment, such as computers and networking equipment, it is generally recommended to use a generator with a THD of less than 5%. An automatic transfer switch, or ATS, is a sophisticated device that automatically switches the electrical load between the utility power and the generator power in the event of a power outage. The ATS continuously monitors the utility power. When the utility power fails, the ATS automatically starts the generator and, after a short delay to allow the generator to stabilize, switches the load to the generator power. When the utility power is restored, the ATS automatically switches the load back to the utility power and shuts down the generator. The ATS is typically equipped with a variety of safety features such as overcurrent protection and short-circuit protection to protect the generator and the connected equipment. The selection of the appropriate fuel tank size is critical for ensuring that the generator can operate for the required duration during a power outage. The fuel consumption rate of the generator is typically specified in gallons per hour or liters per hour at various load levels. The fuel tank should be sized to provide sufficient fuel for the anticipated runtime, with a safety margin to account for unexpected delays or increased load. Regular maintenance is essential for ensuring the reliable operation and long life of the generator. The manufacturer's recommended maintenance schedule should be followed closely. Typical maintenance tasks include changing the oil and filters, inspecting and cleaning the air cleaner, inspecting and testing the battery, inspecting the spark plugs or injectors, and checking the cooling system. Sound insulation measures can be implemented to reduce the noise generated by the generator. These measures can include installing the generator in a soundproof enclosure, constructing sound barriers around the generator, and using sound-absorbing materials in the generator room. Adhering to local codes and permits is crucial for ensuring that the generator installation is safe and compliant with local regulation. Local codes and permits may specify requirements for generator size, location, fuel storage, ventilation, and noise levels. These requirements can vary depending on the location and should be carefully reviewed and followed. Understanding the electrical characteristics of a generator is important for proper application. Generators are typically rated in kilovolt amperes, or kVA, which is a measure of the apparent power. The actual power that the generator can deliver depends on the power factor of the load. The power factor is a measure of how efficiently the electrical power is being used. A power factor of 1.0 indicates that the power is being used perfectly efficiently, while a power factor of less than 1.0 indicates that some of the power is being wasted. Most electronic equipment has a power factor of around 0.8, which means that the generator needs to be sized to provide approximately 20% more apparent power than the actual power required by the load. Generators are also typically rated for a specific voltage and frequency. The voltage should match the voltage of the electrical system that the generator will be connected to. The frequency, typically 60 Hz in the United States, should also match the frequency of the electrical system. When selecting a generator, it is important to consider the starting current requirements of the connected equipment. Some equipment, such as motors and compressors, require a much higher current to start than they do to run. The generator needs to be sized to provide sufficient current to start these devices without overloading the generator. It's also useful to understand generator protection features. Generators are typically equipped with a variety of protection features to protect the generator and the connected equipment from damage. These protection features can include overcurrent protection, overvoltage protection, undervoltage protection, overfrequency protection, underfrequency protection, and short-circuit protection. These protection features are designed to automatically shut down the generator in the event of a fault, preventing damage to the generator and the connected equipment. Lastly, understanding generator grounding requirements is essential for safety. Generators should be properly grounded to prevent electric shock. The grounding requirements are typically specified in the local electrical code. A proper grounding system will provide a path for fault current to flow back to the generator, causing the overcurrent protection device to trip and shut down the generator. This will prevent a dangerous voltage from appearing on the metal parts of the generator or the connected equipment.